So the difference between fission and fusion. If we zoom in on each one of these reactions here, this one on the left, this is fission. And on the right, this is fusion. Now, it's a bit difficult to work out what's going on here with these pictures, but if we look at it carefully, we can start to make sense of it. This little blue thing here, this is a neutron. Okay, so fission, fusion, that's the neutron. So what's going on here? Well, basically you have a nucleus of an atom, often uranium for fission. And what we're going to do is we're going to give it a neutron. Now, a lot of people make the mistake that the neutron is being fired at it quite quickly in order to break it apart, because what eventually is going to happen is it's going to break apart. But it's not fired it. We're not. You don't think about it as like bullets or rocks being thrown out a window, but it's more that it absorbs this neutron, and when it absorbs this neutron, it becomes unstable. So notice also it's still uranium because I didn't give it any more protons, and it's the protons that determine the name of the atom, but the mass number has increased. So 235, now 236. Now uranium 235 is reasonably stable. Uranium 236 is unstable. What that means is, in fact, it's very unstable. What that means is it will almost immediately break apart into two different nuclei of krypton and barium. And these things are very important. They're the same little circle as one above. These are also neutrons. So these neutrons are really important because what they can do is repeat the process. So you can have other uranium-235 nuclei, and these neutrons can cause them to break apart as well. So this continual breaking apart, like one neutron can cause three neutrons to appear, and those three neutrons can cause three more uranium nuclei to break up. That's called that's called a chain reaction. So it's like a domino, but it's actually one causes three, so it actually accelerates. So that's fission. So you're breaking apart the atom there, doing that. Now, fusion is the opposite. Fusion, you get two isotopes. These are both hydrogen, but they're isotopes of hydrogen. This one's got a neutron. This one's got two neutrons, but both got one proton, so they're both hydrogen. And what's going to happen is under extreme pressure and heat, these are pressed up against each other, squashed up so tightly that they actually join together and make this helium nucleus. So, and then in this example, an extra neutron is given off. What this extra neutron does is depends on the situation, but the main thing is that we're producing this. Okay.